Okay, series and parallel. When you are studying electricity, very basic, I think very basic electrical engineering. Series connection. Series connection means one conductor is there. Okay, you are connecting another conductor. You are connecting another conductor. Okay, so one by one you are connecting. This in series. Parallel means you are connecting one conductor, another conductor, another conductor. All the ends will be at the same point, but parallelly you are developing EMF. Okay. So, here if resistance R1, R2, so V, okay, voltage difference will be like this. So, total resistance will be R1 plus R2 plus R3 plus R4 or Rn. And if you have parallel connection means like one conductor is here, another conductor is here, another conductor is here, you are connecting parallelly. Okay. So, this is called parallel connection. This is series, one by one you are connecting. Series means one by one, parallel means parallel, one in the side another, side another, side another. So, when you are connecting a series, your same current, or let's say if I assume water flow, so same water flow is happening, right, if you resemble with fluid flow, but here same current will be flowing, I will be same number of electrons will be moving. Okay. So, but in parallel flow same amount of current may not be flowing because of resistance 1, 2, 3, maybe some more will be there. Okay. So, amount of electron in different wires will be different based on resistance. If one wire is giving very high resistance, then your electron flow will be much lower. Okay. So, you see the left side problem then. Okay. Series problem, here one problem is here. Okay. 1, 2, 3, 4, okay, and electron is flowing like this, current is flowing like this. So, in that case resistance value is given 400, 260 and 100. So, total resistance is R1 plus R2 plus R3 200, very simple. Okay. And if voltage is this one, so V equals IR, V equals IR. So, what is I? I equals V by R. So, V means 20 divided by R means 200. So, this is my ampere. Okay. What is power? Power equals V square by R. So, V means 20 into 20 divided by 200. So, 2 watt power. Okay. This is simple formula. If I calculate for parallel flow, so parallel is here. So, in that case R1 is given 10, R2 25, R3 50 and different current value also given. Okay. So, different current value is given. So, power from resistance 1, power from resistance 2, power from resistance 3 you have to calculate. So, P resistance 1 equals I square R 250, P R 2 equals 100, P R capital R 3 equals 50. So, total P equals P R 1 plus P R 2 plus P R 3 equals 250 plus 100 plus 50 equals 400. Okay. So, very simple formula. Okay. Now, we have seen simple formula for series connection, parallel connection. So, normally in ESP system you are giving all in series, not in parallel. Okay. So, but application wise parallel connection also can be used for certain application, but we are not discussing further. Motor is opposite of generator. Okay. Motor is opposite of generator. So, generator takes mechanical energy convert to electrical energy. Motor takes electrical energy convert to mechanical energy. Okay. Motor normally it will be 5 to 8 meter long, because this is a narrow hole. Normally surface motor you have seen like this big, but some small big also, like toys, small toys will you have, but your electronic watches also will have very small motor. Toys will have this much of size motor, but very big motor also, when few meters size also will be possible, generator motor, because there when you need very high amount of energy, for example electrical train, so they need very high amount of energy, so motor size also will be big. But in submersible system you need very high powered motor, but you do not have space, you have narrow space, casing size normally 6, 7, 8 inch. So within the tubing will be there, so inside tubing the motor will be fit, so it will be 4, 5 inches maximum, most probably majority will be 4, 5 inches, and then when majority of 4, 5 inches or 6 inches, so in that case you do not have diameter you have limitation in diameter. So in that case you have to get longer actually. Okay. So longer, that long can be 5 to 8 feet, sometimes it goes to 100 feet also based on power requirement. Small power requirement, maybe small will be okay, but very high power requirement for very deeper well. So the horizontal plus vertical, all length is very high. So in that case you need very long motor. So long motor will be like tandem motor. Tandem motor means 1 motor, 2 motor, 3 motor will be connected, or modular module, the motors will be connected and it will be making longer. So tandem motor is called if 2 or motor is coupled together to get more power. So one motor is giving 100, another motor will be giving 100, so 2 motor will be 200 altogether almost. And motor torque, if you can calculate like pound feet, so HP into 5250 by N. So this unique conversion factor is 5250 is there. Okay. And how it is working, like say if you have one electrical conductor like this, okay, and you have brushes, commutator brushes, commutator brush, okay, and electric current will be like this and is going back there. Okay, so you are giving electricity from here maybe, and when you are giving electricity, I already wrote that coil will create magnetic flux, okay, because of electricity. Now when magnetic flux will be cutting your actual magnet flux, so those will create a force actually. Okay, when that force is created, so if you arrange properly that flux system, electric generated magnetic flux and magnetic generated flux, so then magnet can rotate or your coil can rotate, so you can manage that one. Okay, when it is rotating, so EMF will change or your magnetic pole will change, so gradually you get continuous rotation. Okay, and to know how does it work, in my course I am not discussing details, so you can go through several videos of the animation videos are in YouTube. Here I have given one example like animation video. So there are several videos also, you can watch how these poles are getting changed and how this motor is rotating. Okay. And motor I will have one dielectric fluid. I told dielectric fluid is that it prevents or electric discharge. If there is spark is trying to happen, so it will be preventing, because 2 electrodes are there, in between fluid will be there. Okay. So because of fluid there will be no spark, almost negligible spark. Okay. And it will be used for high voltage applications, transformers, in motors, in generators. This oils will be there. This is mineral oil, normally will be paraffin based or naphtha based oils. The dielectric strength of a transformer oil is defined as maximum voltage that can be applied across a fluid without electrical breakdown. So how much voltage you can apply using a dielectric fluid, that will be the measurement. Normally they will be using kilovolt term. Okay. So here one picture I have taken from Kermit Brown book. So this picture shows you have one big shaft. Okay. Big shaft is going from motor. Okay. Motor is here. So motor will be giving torque. Okay. And this will be connection, motor coupling. Okay. So motor is having what is happening, like how to connect. So one motor shaft is there, one turbine shaft is there, your pump shaft is there. So pump and motor shaft will be connected like this. Okay, then you will be rotating. So there's maybe key wave will be there and will be coupling sometimes. Sometimes there will be spline connection like this, connect it and move continuously. When you connect into shaft, so main problem occurs alignment. If aligned, those shafts are not, let's say shaft A, this is motor, say motor shaft. This is turbine shaft. Okay. So motor, turbine. So there will be coupling. Okay. Okay. So, if motor and turbine shaft are not on straight line, so let us say one making angle like this. So, when it is trying to rotate, this is trying to rotate, okay, this is motor shaft and turbine shaft is here. So, turbine shaft will take torque from it and it will rotate impeller, right. So, instead of straight, it is having angle like this. So, it is trying to rotate, it is having angle, because the angle this shaft, that impeller shaft or pump shaft, it will having lots of friction and vibration. Okay. So, you cannot make these two shaft connections or joint, this joint, okay, very strong. If you are making very strong, then if there is any bend, it will try to rotate, but it is not rotating because this bend is there. Okay. So, you have to give some flexibility, axial flexibility, so that if there is any misalignment because of axial issues, so there will be axial flexibility, so alignment issue won't be there. Okay. Alignment, how to do flexible alignment. Flexible coupling. Okay. So, flexibility you have to give. If both shafts are strongly holding together and some bend is there trying to rotate, because of this bend there will be very too high amount of forces on bearings and other aspect. So, things can break. So, what you have to do, you have to give little bit flexibility, axial flexibility. For example, my shaft one end is here, another end is here. Okay. So, if there is any axial movement, so I have space here because of this axial movement. So, any axial problem here, it will not be transferred, or it will be rotating, it will also be rotating because of this type of specific shape. Again, you have to give some sort of flexibility, like it is not tightly fit like this. So, if there is any misalignment like this, it will also be no problem. So, that is why we give flexible coupling in between shafts actually, so that no vibration will be transferred, no axial extra load will be transferred, no misalignment. Misalignment means both axes must be on same straight line, but when you are making 100 feet long shaft of motor is 100 feet, that means shaft also 100 feet and pump also maybe 100 to 100 feet. So, 100 feet, 100 to 100 feet, so long and keeping on perfectly straight line is very difficult. So, you have to give certain sometime misalignment that flexible coupling system, so that one shaft should not transfer uneven forces to another shaft. Okay. And tandem motor also, that is why people will be creating, so that one shaft will be connected and little bit flexibility will be given. So, one shaft some misalignment creating, so only it will be transferring torque. So, shaft is entitled to transfer torque, not any other forces. Okay. So, if it is transferring any other forces, then you have to restrict, you have to give some bearing arrangement or thrust bearing or radial bearing or flexible coupling, so that no extra force should not be carried from motor to your pump. If there is, then make flexible coupling, give some extra bearing, give thrust bearing, so that it will be transferring only torque. Torque means power, rotational speed omega into torque equals power. So, it will be transferring only torque, not any other force. Okay. So, that is why you have to give flexible coupling, radial bearing and thrust bearing, and if possible make shorter shaft, but it is not possible. Shaft as a definition of shaft is equal to cylindrical element, shaft cylindrical element, cylindrical, you can say rod, cylindrical rod, transfer torque only, transfer torque only for ESP systems. Okay. If you see surface shafts, let us say shaft used for marine machineries or aircraft, so they can transfer some bending moment and other moment, other forces also will be there. For your ESP system, shaft will have only torque. Torque means shear force will be there, no tensile force or no compressive force. Okay. If tensile compressive force is there, then you have to make proper mechanism, so that those forces should not get transferred from one shaft or one component to another. Say motor to pump or pump to motor should not be transferred. Okay. So, here some more items are there. Thrust bearing is there, later I will discuss. Radial bearing, this is radial bearing, and this is thrust bearing, this is already done, thrust bearing. motor head with bearing in place. Okay, motor head here. Here one system is here, you can see this is called pot head. Okay, this is called MLE or the cable end. MLE is cable end pot head. So, cable end will be coming, cable means from surface electricity is carrying, and I have motor here. Motor will have some catcher like this. Okay. So, you just put it properly, so that it will be properly insulated. Motor will get electricity from the cable, but no water or other fluid will be entering there. So, it will be designed properly because you do not have much space inside wellbore. So, you will have to design such a way that it will not create any insulation issue or any sparking issue, but it will be holding properly done. Okay. ESP motor, so ESP motor will have one rotor, one stator. What is rotor? Rotor means rotating part. The shaft will be connected to motor, right? Stator, sorry, shaft will be connected to rotor and stator is fixed. Okay. So, if I draw one motor, it will be looking like this. Okay. This is my earth surface, this is my rotor. Okay. This is stator, this is rotor. So, rotor stator is like this. Okay. Okay. So, rotor will be rotating, name is rotor. Stator means not rotating, static. Okay. So, outer surface normally it will be static, fixed, bolted somewhere else, and inside rotating part. Okay. Both will have magnetic coil. One magnetic coil will be excited, so that will create extra force to another coil. Because of that, rotor will be rotating continuously. In submersible system, you are using 3-phase motor and 3-phase induction motor. Okay. 2-pole 3-phase induction squirrel cage type normally motor will be there. It will be filled with dielectric fluid, and normally it will be more than 28 kV strength must be there. If it is having lower strength, then spark can occur. So, high strength dielectric fluid you have to use. Normally RPM for especially US unit, they will be using 3500 RPM at 60 hertz. Okay, the frequency. If you have lower frequency, let us say 50 hertz, then speed will be like about 2900 RPM. Okay, for 50 hertz. Rotor and bearing strap and shaft in rotor. Okay, rotor and bearing. So, here my shaft location, you see the picture, shaft, and here is my rotor. Okay, rotor is like this. Rotor will have like this. Okay, rotor, this will have conductors, this gaps. Okay, this will be conductors, and my stator is outside here, outside laminations, this is lamination. Okay. Okay. So, stator slot is here, and stator laminations are here, stator lamination, and in between rotor stator there is air gap. Okay. So, air gap will be filled by your dielectric fluid. Okay. If that air gap is not fluid, then spark can occur. It is very close, maybe 1 millimeter gap will be there. Okay. And very high voltage is created. If you are not giving the dielectric fluid, spark will be created and your rotor will not rotate, rather it will burn. But if you have proper dielectric fluid, then flask will be passing, and flask will be giving force to your rotor lamination. Rotor lamination, rotor core will be getting that force and will be trying to rotating. Okay. So, rotor lamination. So, rotor lamination will be here. Okay. Because of this rotor lamination, a 3-phase connection will be here, 1, 2, 3, 3-phase connection. Okay. So, 3-phase connection is giving, you have rotor, you have stator, the rotor is getting force from stator, and because of that the rotor is rotating. And for detailed further study, lots of animation, again animation videos are there, please try to watch, so that you will understand how this electrical motor is working, because you are studying artificial lifting system. So, lots of time will be talk about motor, rotor, pump. So, motor basics also you should understand. So, I am giving some basics, but some more basics you should understand from your general YouTube videos. Okay. So, stator core electrical field is a motor compressed of housing material, stator core and stator winding. Housing material, that outside material will be covering the whole system, so that no water or some debris should not enter into the system, and your dielectric fluid will be contained within the system, and if there is any heat generation, there will be some fan in the motor, so that heat can get dissipated. So, dielectric fluid actually it will be trying to dissipate heat, but still heat generation higher, then one fan also will be there, integrated part of the motor. So, that fan will be producing lots of airflow. Why fan will be using? Fan will be creating turbulent flow or forced convection heat transfer. So, normally let us say you take one cup of coffee or tea, okay. So, and there is no air blow, what will happen? Because of natural convection, liquid particle will be moving liquid surface, and convection heat transfer will be there. Because of that, slowly it will be cooling down, okay. It will take some time, but if you have air blow or fan on your overhead fan is there. So, because of that, lots of convective heat transfer will be happening, forced convection heat transfer. So, because of that your cooling rate will be higher. So, that is why this fan will be there. So, you are increasing cooling rate using convective forced convection heat transfer. Because of forced convection heat transfer, motor temperature will be going down. So, that is why normally there will be one fan also, motor fan. But in your submersible pumping system, you do not have fan, because your space already limited. So, in that case, an air also not there inside wellbore. So, what you do? Your fluid from wellbore you are pumping, so that fluid will be carrying heat. Okay. So, if there is any heat generation, that fluid whatever you are pumping, that fluid will take heat and it will put to the surface. So, the whole material system, your submersible pump, stator, rotor system should have good conductive material, and your inside transformer oil or motor oil should be properly placed, so that it can conduct heat properly, and your insulation also should be proper, so that wellbore fluid should not enter. So, if still there will be heat generation, that generated heat must be carried out to the surface. If you are not carrying out, then heat overheating will be there. So, that will be creating a big problem. Okay. So, stator winding made from polyimide or PEEK material, okay, and rotor inside stator core, okay, that is fine. Copper bus will be using in rotor, okay, copper high conductive material. So, you are not creating resistance there, rather you are creating force. Its main purpose to produce force, right. Force will be converted into torque. So, how force is converted into torque? Force into radius equals torque. Okay. If shaft radius r and you are getting force, then torque will be F into r. Transformers, normally there will be step up transformer or step down transformer. If you have very high voltage and your requirement, let us say 220 volt. So, in that case you have to reduce voltage, otherwise whole system will get burned. For example, your system can take only 220 volt of in fluid mechanism pressure, and your volt is very high, means very high pressure, the whole system will get destroyed. So, you have to reduce using certain mechanism, then you can give to the system, so the system can be safe. So, how the system works? So, normally it will be like this, one rectangular shapes things, okay, and it will be like this, okay, and lots of coil will be there, and here also lots of coil will be there. Okay. So, left side is called primary, this is called secondary. Okay. So, primary will be supply voltage, secondary will be your whatever voltage you are taking. So, and that voltage conversion is based on your number of turns, how much turns you are giving in secondary, how much turn you are giving in primary, and inside this is a magnetic core. Okay. So, if primary voltage 120 volt and secondary and it is having 100 turns, this number of turns, how many turns of wear is there, TURNS, and this is having, let us say, 1000 turns. Then what will be the voltage here? The formula is that ES equals 1000 divided by 100 into 120. So, 1200 volt you are creating. So, actually you stepped up. So, whenever you are reducing, so just you have to use opposite way. So, they can reduce your voltage. So, normal notation will be like this, another. So, you have to draw properly actually. Okay. This is primary, this is secondary. So, instead of that central core, we do not draw many time. So, use only in this circular shape. Okay. Transformer, when we are talking about transformer, we are talking about transformer oil or motor oil or the dielectric fluid. So, how they test the dielectric fluid? Normally, they will have one vessel, okay, and there will be two small beads will be there. This will be 13 millimeter each, and there will be certain gap, let us say 2.5 millimeter gap, and you use potential, okay, and you put this on dielectric fluid. Okay. Now, use dielectric fluid and give higher potential and see how much voltage it can withstand. If it can withstand, let us say 33 kV for 40 kV. So, based on that you rate this dielectric fluid. Okay. So, laboratory practice will be like simple test, one box is there, 2 electrode, and you apply different voltage and you measure, and again you can reduce the or increase the distance between two also. So, that way you can measure this dielectric fluids quality. Okay. Now, here is one problem is there. Transformer converts 7200 to 480 volt, 2 sets of coil wrapped around iron core. Transformation ratio is 7200 by 480. This is called transformation ratio. Okay. So, you remember the term. So, rated, the definition is rated kVA, transformers are kilovolt ampere. Okay. So, kV into A. So, 11 kV to 420 kV, very common type of transformer. Now, from transformer you have to go to switch box, then venting box. Okay. First, let us go to junction box. Junction box means you have wellbore. Okay. Is cemented. Now, your tubing things are there, motor is here, cable is going through this. Okay. Now, your cable is going out, it is going to one junction box. Okay. From junction box it will go to your switch box. Junction box, sometimes venting box or vent box they say. Okay. So, junction box normally it will be 2-3 feet above the surface, and the cable normally buried cable. Okay. Surface cable will not be there, and if there is any gas inside this cable is there, then junction box will be venting out all those gases. So, that is why it is called junction box. So, this gas or anything should not go to a switch box, because switch box will have more equipment, for example, a variable frequency drive and switching cut and everything. So, if some gas is going into switch board, so there can be a fire or sparking. Okay. So, to avoid that one, junction box will be controlling all the aspect, and it will get electricity from your switch box. Okay. Now, switch box it will go to transformer. Okay. So, transformer will be given to switch box will give to your junction box electricity will go directly to your motor. This way whole surface system will be working. Okay. This junction box will be providing easy accessibility, and the distance between the systems will be maintained like this, almost 50 feet will be there from your wellhead to your switch box. Okay. and 15 feet will be there from well head to a junction box. These are commonly people using for safety purpose only. Okay. Switch box. Now transformer, switch box, junction box, well bore, right. So switch box, what the contents inside the switch box will be like one VFD system will be there, and switching, overload, underload and controller equipment will be there. Okay. So this is actually control box, you can say. You want to increase turbine pump speed, so again you have to come here, not junction box. Okay. Junction box purpose, normally you are not touching junction box, you are touching only this one for controlling your systems. So for automation also you are controlling from this one only, the switch box only. Okay. On off switch box will be there, and available different ranges 440 to 4900 volt, around 5000 volt will be there. Okay. And it will have one VFD, variable frequency drive also. So variable frequency drive, actually it will be changing speed, electrical frequency 60 hertz to 50 hertz. So if you are changing electrical frequency, your motor speed will change. Motor speed is changing means your pump speed changing. Pump speed changing means your whole fluid column or hydrostatic head development or increasing energy into the fluid will be changing. Now cable. Okay. So cable size, normally the voltage drop will be 30 volt to per, recommended voltage drop should be 30 volt per 1000 feet or less than 15% of motor nameplate voltage. Okay. So voltage drop should not be so high. So if you want to avoid voltage drop, then you have to follow certain basic formulation. For example, you have to use copper conductor, maybe multiple strand you can use, and based on that your space you can change your cable, that will be flat type cable or round type cable. Then cable length, total length should be 100 feet more than the measured pumping setting depth to have sufficient length for surface connections. Okay. The surface connection means well bore, then junction box to your switchboard. So all this length also you have to count and you have to calculate. Cable venting or vent box should be there, so that any gas coming out from the well bore, that will be going out from there. Copper or aluminum can be used for your cabling operations, but normally copper will be used. And American wire gauge AWG, normally this will be their measurement. For ESP system 1, 2, 4, like single strand, two strand. So these will be saying like that. Cable insulation, API standard you have to follow, and you have to insulate the cable. Insulation means so that electrons should not go out, and this whole system must be safe. And if you see this one braided cable, so cable will have initial insulation, then you will have one jacket, then will be one armor. Armor means mechanical armor, so that whole inner softer material. So one metal conductor is there, after the softer material maybe rubber or other material there, and then outside one metal cover will be there. So metal cover will be covering the whole system, so that any wear or tear out will be prevented. Okay. Common voltage rating for submersible pump cable 3, 4 and 4 kV. Okay. And this is one circular cable, this is one flat cable, this is single rod, this is multiple rod, and multiple rod are normally arranged like this. Okay. This is called strand. Sometimes strand will be just twisted. Okay. And in between the gap is there. Okay. So when, because it is circular shape, so some gaps will be there in between, so those gaps will be carrying your gas. So that is the problem. Okay. The single strand is okay, but single strand will be more stiff, multiple strand is more flexible. Already you have seen the formula for